Hello everyone, my name is Arohi and welcome to my channel. So guys, in my today's video I'll show you how to detect, track and then count the number of vehicles based on the direction of their traveling. Suppose the vehicles are moving upwards, we'll count that separately, and the vehicles which are moving downwards, we'll count them separately. Okay, and guys, for today's class I'm not training the model, and we are just using the pre-trained model, YOLOv8 pre-trained model, which is trained on Coco dataset. And Coco dataset have various classes and some of them are car, bus, truck. So we will use the YOLOv8 pre-trained model to perform detection, and then we'll track and then count the objects. So let's start. So guys, to run today's code you need Ultralytics package, and you can install it like this: pip install Ultralytics. And after that, I'm just showing you the version of Ultralytics which I'm using. So this is the version, and then I'm importing all the required modules, and here in this line I am just loading the pre-trained YOLOv8 model which will help us perform detection. Okay, and then in this class list, this is the list of Coco dataset classes, and here I am just creating an instance of tracker class, and I'm getting that from here. And this count variable I'm using it, I'll tell you later on where we are using it. Okay, and then here we are reading a video on which we want to perform the testing. I'll show you the detection, tracking and the counting part on this video. And after that, over here we are just reading all the frames of the video until the time there are no more frames to read, and then we are resizing all the frames to this size. And here in this line we are using the YOLOv8 model to perform prediction on each frame. So what we are doing here, we are performing detection on each frame of this video, and the results are getting stored in results variable. And then we are fetching the data related to the bounding boxes, and then the confidence score and the class ID, and we are storing that in this variable. In this variable over here we are creating a data frame so that we can have each value in a separate column. For example, the bounding box, when we so how object detection model work? Object detection model provides you a bounding box coordinates for each object, and bounding box coordinate means x min and y min value, x max and y max value, and there will be some kind of confidence score with it, and then the class ID. So all these things we are storing in a separate variable. That's why we have created a data frame. So let's print this data frame so that you'll get an idea what kind of values we are having in it. Okay, so this is the video, and for this video, for the first frame, these are the values for the first frame. So there are 11 cars, 11 different objects detected in first frame, and 5 on this column. These are the class IDs, class ID 2 and class ID 7. See, you can see we have class 7 or 2. So these are the two different kind of classes we have in the first frame, and 2 ID is 0, 1 and 2. 2 ID belongs to the car class and 7 ID belongs to the truck class. And then the first column is having the value of x min coordinate, this is y min coordinate, this is x max, and this is y max, and this is the confidence score, this is the class ID. For each object we have values like this. So this is what this data frame have. Okay, so let's comment it and let's perform the next task. Now the next task is, okay, so I am pasting the work here. So now I have created a separate list. So guys, why I'm creating this separate list? So for my today's class, I only want to work for car class, means we will count the cars only. We are not focusing on the other vehicles right now. We will only count the number of cars. Okay, so for that I have created a separate list, and in this list I only want to store the bounding box coordinates of the car class. So you can see here the row 0. What is there in 0? This coordinate. What is there in 1? This value. and in 2 we have this value, and in 3 we have this value, and in 5 we have the class ID. Okay, and in this variable C class list, remember this is the list we have above where we have all the classes of this Coco dataset. So what we are doing, we are just getting the class name for the class ID. Okay, and if car in C, we are not using this condition right now, so we only want if car is there in this list, then we are appending this list and we are storing the bounding box coordinates. Okay, so now in this list we have the bounding box coordinates of car class. The next task is we will provide these coordinates to the tracker so that our tracker can track those objects in the all the next frames. Okay, so for that we are using this tracker.update. We are updating the tracker with which list? This list. And what is there in this list? The bounding box coordinates of car class. Okay, and then here x3, y3, x4, y4, these are the new bounding box coordinate values for tracking. Okay, so cx and cy. Now let's understand what is this cx and cy. So guys, when we talk about bounding box, so we have x min and y min value, x max and y max value. So there the center of the object is our so if we want to know the center of the object, so that's the value we are getting. Center of the x coordinate and center of the y coordinate we are getting over here. Okay, and then we are using this cv2.circle on each frame, and this cx and cy is the center of the bounding box, and we want to draw the circle or a dot in the center of each detected object. Okay, and on that dot we want to provide this text. What text? The ID, the tracking ID. Which tracking ID? The ID we are getting from here. So now with this code what we will get? We will get the tracking IDs and we will get a dot in the center of each detected object. Okay, so let's see what kind of output we see again. So here you can see, so every detected object in the center there is a red dot and the ID, right? ID is assigned to the object. Now we want to count the number of cars on the basis of the direction of their traveling, right? Some of the cars are moving upward, some of the cars are moving downward. So on the basis of the direction of their traveling, we want to count them. So for that we will draw the two lines on the frames. Okay, so let's do that. So here I have pasted this code. What I have done, this is these two lines are responsible to draw one line, and these two lines are responsible to draw another line. So basically we are drawing two different lines. Let me show you the lines first, then I'll explain you what it is. See, we have this red line and this blue line. Okay, so what we have done, okay, first of all, so this is the first frame. So now in this frame we have the detected object and there is a red dot in the center of that object and the tracking ID, and then we have red line and then we have blue line. So these two lines are for the red line. So this value is the starting point of the line, the starting point, red line. So whenever you want to draw a line, there are two values are required. X value means how many pixels from here, and pixel value from here. X value and the Y value. So this is the first point of the line and this is the end of the line. X value and the Y value. Okay, in the same way, and then after plotting this red line, I have written red line on it, and for that I've used this put text and then I've written red line, and at this location I want to write. In the same way for the blue line, this is the starting coordinate and these two are the end coordinates. So guys, next thing is these values. So why I'm writing these values over here? Because we will need these values in some time. Okay, these two values, red line y and blue line y. Now let me explain you what it is. This is red line, y value of red line and y value of blue line. So we are saving it because in some time we will write a condition that if cars are touching the red line, then we want to perform something, and if cars are touching blue line, then we want to perform some action. Okay, so for that we need the pixel location, like where the y line is, where this red line is exactly, and where the line y is exactly, so blue line is exactly. So that's why we have stored their y values, red line y value and the blue line y value. Okay, so we have stored them in this variable. So guys, now I'm going to write a condition that only put this red dot and the tracking ID on those cars which are touching the red line. Right now you can see that the cars which are over here or the cars which are over here, every object which is getting detected and tracked, our algorithm is putting this the center point and the tracking ID. But now we want to write a condition that we only want to put the tracking IDs and this red dot on those cars which are touching this red line. So we want to write this condition. So let's write that. So guys, now I'm just commenting this part, the current code which is responsible for putting the red dot and the tracking ID. Okay, I'm commenting that part. And over here I have written this condition. This condition is for red line, okay, the first line. So this is the condition. Red line y value, if red line y value is smaller than cy plus offset, and if red line y value is greater than cy minus offset, then what we want, this, what is this down? Let's understand this down first. So this down is a dictionary, and let's define this dictionary over here. Let's create a dictionary down. Okay, so we have this dictionary here. This dictionary, why we are creating this dictionary, guys? So what we want is, in this dictionary I will save the tracking ID and the current position of the detected object. Down dictionary ID of the detected object equals to cy. What we are doing over here, cy is the current position, and we are saving the IDs of the cars and which are touching the red lines. And if ID in down means if the ID which is getting detected, if that ID is present in this down dictionary, then we will put the circle in the center of that object, and then we will put the tracking ID on that object. Okay, so let me print the value of this down so that you can understand what kind of value we will get. Okay, so let's print the value of down over here and enter. Okay, we have to escape this first. Red line y is not defined. Okay, so we have to define these values above this condition because these values are getting used in this code, right? So let's define these values here. Now let's run the code. Offset, let's provide offset also some value to it, like 7. What happened? Oh, I have to provide it over here only. Offset. Okay, now let's run it. Here you can see guys, this particular car is touching the red line. The center of this car is touching the red line, so that's why the tracking ID and the center dot is assigned to it. Now here also you can see this is the down dictionary, the ID and the current position of that object, ID and the current position of that object we have in it. Now let's run the second frame. Is there anything in second frame? See, earlier the current position was 194. Now the current position is this, but the object is same, the vehicle is same. So this is how you can see the value. Now let's move. In third frame, the ID is same. The position of that object is changed by 1 pixel. Let's see. Now in next frame, there is no detected object. Now let's, okay, over here. Now this car is touching the red line and you can see our down dictionary now. We have this record, right? The previous one and this one which is detected just now. The ID is 0 and the current position of that object is this. So now let's see few more frames to understand. Now this car is touching it. Let's scroll down and see our dictionary. Now we have this down dictionary have 3 IDs and 3 different positions of the cars which are touching the red line. But once the car crossed that line, you can see that once the car crossed this red line, okay, so after that the ID and the center point disappear. Okay, here is our code. So this is what we have done. Clear? So guys, I hope now this is clear that what this down is. What this down is doing, I hope this is clear now. Okay. Now if ID is present in down, then only we are printing this, putting this circle and text on it. Now let's comment it. Now same way we will write the condition for blue line also, that we only want to put the red dot in the center of the object and we only want to provide the tracking ID to the car, the cars which are touching the blue line. So let's comment this code for a while. Let's comment it, and this we have mentioned above. Now let's put the condition for blue line. So this is the code for blue line. So the code is exactly same, guys. The only difference is here we are defining the blue line y value and the condition is similar. And this time earlier we have used the down dictionary. Now for this we have created another dictionary with the name of up. Let's create that dictionary here. Oh, sorry. So this is the dictionary. Now this dictionary will also store the same kind of data, the ID and the current position of the object. So here it is. Yeah, here it is. If ID is in up dictionary, then only want to put the circle and the text on it. And if you want to see, let's see, if you want to print it, we can print it. Let's print the up dictionary. So right now the dictionary is empty. So let's move to the next frames and see when car comes closer to the blue frames, and then here in this frame, here. Now after so many frames, this particular car is touching the blue line. Now let's scroll down. See, our dictionary is empty. In the last frame our dictionary will have the data. Let's see here, 0, ID is 0 and the location of the current position of the vehicle is 263. Okay, so this is the condition for blue line. So we have the condition for red line and we have the condition for blue line, and the condition is we are saving, we have 2 separate dictionaries, down and up. Down dictionary is storing the data when the car is touching the red line, and up dictionary is storing the tracking ID and the current position of those cars which are touching the blue line. Now we want to combine the condition while. Now what we exactly want to do? So guys, in the beginning of our today's class, I've told you that in my today's class I'll show you how to detect, track and then count on the basis of the direction of their traveling. Now the cars on this road, they are traveling downwards, right? They are traveling downwards, and the cars on this road, they are traveling upwards. So we want to get the count separately, that how many cars are moving downwards and how many cars are moving upwards. So here if we'll see, can we say that if the cars are touching the red line first, that means the cars are moving downwards, and if the cars are touching blue line first and then the red line, then cars are moving upwards, right? The condition is very simple. If the cars are coming from upward, the cars will definitely touch the red line first and then they will touch the blue line. And if our cars are moving upward, they will touch the blue line first and they will touch the red line. So this condition we want to implement, and we will get the count of the cars direction wise. Okay, so let's do that. So now let's write the condition which I've just told you, okay, for both the lines together. So let's comment the code for this blue line also. Let's put, and here I'm writing that code now. So this is the condition. So this is for the red line and this is for the blue line, and the condition is, see, the condition which I've just explained you, I've just combined that condition. So, and one more thing I want to tell you, when we will update our counter over here, suppose if the cars are moving downward, so we are writing a condition that if the car is touching the red line and after that car is touching the blue line, then we will update the car car going down counter, okay? And if car is touching the blue line first and then it is exiting from the red line, so when it will exit from the red line, then we will update the up counter, okay? And down counter will be updated when the car crossed the red line first and then it crossed the blue line. When it will cross the blue line, we will update the counter going down, okay? So that's the condition I've written here. So this is the condition. This is the same dictionary, down dictionary I've explained above. And if ID in down, then we just added the condition, one more if condition over here, that once it crossed the red line and then it will cross the blue line. So this is that condition, that when it crossed the blue line, after that put the circle in the center of the object and then put the ID on it and then update this counter down. Now we will create this list, counter down and counter up. We need two separate lists. Let's create these two lists. Counter down and counter up. These are the two separate lists. So the counter down list will store the counts of the car which are moving downwards. Means the cars which will touch the red line first and will touch the blue line, then this counter down will be updated, and this counter up, the cars which are touching the blue line and when they touch the red line, this counter up will be updated, okay? So let's come here. So this is the counter down we are pending and this is the second condition, okay? Here we are updating the counter up. Now we want to show that counter, the number of count on the frames. Let's write few lines to show that. So let's put that code here. Downwards is the variable in which I'm just checking the length of counter down and I'm showing on that screen going down and like this. And we are checking the length of counter up. We are storing it in upwards, and then on the frame you will see going up, and in that we are showing it, okay? So now let's see the output. Let's see the output. Okay. Now let's see the output. So the counter is increasing, going down counter is increasing, and going up counter is also increasing. Now let's understand the count frame by frame. So let's check it. So this is the first frame. Right now both the counter values are 0. So this car is entering the red line, and right now see the going down value is 0 because the condition is the car when it will cross the red line first, and when this car will touch this blue line, then we will update the going down counter. Okay, so now just let's keep track of this car, and now the center. Okay, now the center of this car touched this blue line and our going down counter is incremented. Okay, so now let's see about this car. Second car is coming. The center of this car touched it and the counter is incremented. Now this car touched it, the counter increased now. Now see, on this side, this car is moving upwards. So this car crossed the blue line. When this car will touch the red line, our going up counter will also be increased. Let's see. See, these two, the counter increased, and we are just seeing this now. See, this touched the center of this object, touched the red line, and our going up counter increased. Okay, so guys, this is how you can detect, track, and count the number of vehicles based on the direction of their traveling. And I am providing the link of this code in the description section. You can try this code, and I hope this video is helpful. So guys, if you like my video, please like, share, and subscribe my channel. Thank you for watching.